Hello, everyone. Thanks so much for joining us for today's webinar, Network Densification, Providing a Consistent 5G Experience. I'm Catherine Sbeglia, and I'm the technology writer at RCR Wireless News. As digital services evolve and users continue to demand faster speeds and higher connectivity, network densification is proving to be a key driver for enabling successful 5G networks. The process of increasing available network capacity through the addition of more cell sites will allow 5G to achieve the speeds necessary to address the new and demanding use cases emerging for cellular connectivity. Today, we'll be taking a closer look at the challenges and opportunities presented by network densification, and we'll explore how to best approach those challenges and opportunities. Please keep in mind that we're recording this webinar and the slides and video will be made available on demand. For today's webinar, we have 3 subject matter experts. So please use the webinar portal to submit questions throughout the conversation. We'll get to as many of those as possible towards the end of our time. Joining me today is Tom Kane, President of NB+C, Brian Deutsch, CEO of Pivotal Commware, and Hongtao Zhan, Founder and CEO of SureCall. Now, before handing it over to our speakers, I want to get into the background of the issue a bit. For the last 3 decades, the demand for mobile data has grown exponentially. In fact, an IDC study reports that worldwide mobile data traffic has grown at a remarkable compound annual growth rate of 50% since 2010, driving tremendous capacity expansions, resulting in higher amounts of cellular radio sites and the deployment of additional wireless spectrum. Further, continued growth of roughly 30% per year is expected as the industry moves towards 5G. This means that operators need to expand capacity by a whopping 10 times in less than 10 years, suggesting that the next few years will see a massive need for more network infrastructure. But how dense is really dense enough? Industry Trade Group, CTIA, forecasts that by 2026, more than 800,000 small cells will be deployed in the US, up from around 86,000 in 2018. And for a more global outlook, the Small Cell Forum conducted a survey in the 4th quarter of 2018 called Small Cells Market Status Report that forecasted a total of 10.25 million new small cells deployed between 2017 and 2025, led by investment in the US, China, and Japan. The report itself explored 4 deployment categories: urban, enterprise, residential, and rural and remote, and concluded that the largest increases will come in the enterprise and urban categories, with respective 2017 and 2025 totals of 5.5 million and 2.86 million small cells. Increasing network capacity through the addition of more cell sites will certainly go a long way in achieving the coverage and speeds necessary for the demanding use cases emerging. However, the sheer number of sites needed to get the job done is in and of itself a limitation, as the idea that we need millions of these sites is, in many cases, being met with resistance by consumers and local governments around the world. The challenge then becomes twofold: how operators and vendors can tackle the complicated and massive task of mapping the most effective and efficient deployment strategy for thousands of cell sites, and how to do so without alienating the communities being both served by and inconvenienced by them. And these installs, no matter how aesthetically pleasing and low-key the operators try to make them, will all need an antenna, power, fiber, and so on. In other words, these build-outs will, without a doubt, impact the landscape of a community. And so with that, I'm going to turn it over to Tom, who will talk more about these issues and the importance that balance plays in network densification.
Great, thanks, Catherine. Catherine teed it up very well as far as densification. So I'm Tom Kane. I currently serve as the president of NB+C. We specialize in network deployment for all the wireless carriers, small cell providers, and tower codes. NB+C's been around since the mid-'80s and did a lot of 1G work. So we're proud to say we've been involved with every G. So today I wanted to go 5G, we all know that all the macro sites we've developed in the country will need to be modified for new 5G equipment. So that's a big lift we're all aware of. And in fact, many new macros will be needed as well. Jumping to the next slide. I wanted to focus today on what Catherine alluded to or referenced, which is the need for potentially 800,000 small cells as we densify for 5G. So we need high volume. We've been a leader at NB+C and have worked on or are in development of 10,000 plus small cells today. And we specialize in that deployment. And for those of you who don't know us out there, NB+C specializes in we call it the right side of the country as a regional player on the right half of the United States. Next slide, please. So every carrier has a different spectrum holdings, and they have different programs and plans as it relates to deploying that spectrum and what they're going to do. I'm not going to comment too much on individual carrier plans for that, but small cells in general are a part, either a significant part or a part of every major carrier's plans today. So today, the current status has been that small cells via portion of CapEx and by count have accelerated dramatically over the last 5 years. Current siting for those are challenging due to lack of municipal process or understanding or fear of that architecture. We have a situation in the current environment where the utilities, we need to install on utility infrastructure pretty much throughout the country. And currently there's a bit of a disconnect between telecommunications industry and the utilities. There's some great utility partners out there right now that are ahead of the curve. However, there are several other utilities we come across that lack process or manpower for high volume small cell deployment. Fiber is a challenge for costs and or implementation. Today, most current siting, not all siting, but most current siting on small cells is single carrier. And every project has a different roadmap due to municipal, utility, Department of Transportation, community issues. So that makes current deployment a bit of a challenge. Next slide, please. So for us at NB+C, what do we see today and what's going to happen in the near term? You know, as I mentioned, we've worked on every G, and 5G is definitely the most challenging because we're moving into the right of way. We're moving into the utility infrastructure that has been used in the past for some DAS systems, but nowhere near the volume we're talking about today. So I think industry and the country, really we need to develop additional partnerships with the utilities and municipalities so that we can get repeatable processes and procedures in place. Fiber infrastructure is tremendous, and that is a big need out there. We see the fiber expansion, we see the fiber investment, and that'll be a critical path because every single small cell needs to be fiber fed, as most of us on the call know. Again, we need to make these installations for small cells a little bit more commercialized, a little bit more consistent, without the very different roadmaps we see on every single project today. I will say, as far as what's next, a near-term development is WIA, the Wireless Infrastructure Association, has pushed forth a 5G upgrade order in front of the FCC for June 9th. So that's pretty exciting. It's lobbying for a clarification of Section 409, which will allow for more rapid deployment and allow for more commercialization. So that's very near term and very exciting for the industry. We need to continue to decrease carrier CapEx per small cell if we're going to hit that 800,000. Many of these projects are somewhat expensive today due to the issues I've already mentioned, and so that will be important. And then one thing I think that's important for us to hit the scale we need to, and for the 5G experience, it's my last bullet here, and it's in the press quite a bit. The carriers need to have a return on their investment. These small cell projects are incredibly high volume. They're not cheap. We're talking, as Catherine mentioned, about 800,000 in the country. So these are very expensive CapEx projects, and clearly our carrier partners and the carriers in the country to serve the communities we work in, they need to monetize that. They need a return. There's a lot of conversation around that. I'm optimistic about that, but it's very early. You know, we're talking IoT, we're talking smart cities, we're talking smart cars. We're also talking different and more significant revenue sources from the consumer. So that will be an important part of the puzzle if we're going to move forward and scale to that 800,000 to million small cells that we're talking about. Last slide, please. So, and again, to do that, you know, what does the next 5 to 6 to 7 years look like for deployment? And what would be the challenges to us hitting that number that we talk about for the industry? So first and foremost, as I finished the last slide, again, if the carriers cannot monetize the investment will slow. They're smart businesses, smart large public businesses that are going to deploy capital where they're going to get a return. So that's first and foremost. I'm a big believer that the industry needs to be very good and very self-policing. We need to deploy things into our communities we work in that we would be comfortable having in our own communities. I've seen some pictures of small cells out there that I would not be proud of if we built them, number one, and I certainly wouldn't be happy to look at as I left my community or was traveling in my community every single day. So the community needs to the wireless community needs to self-police and make sure we're doing a good job and being good corporate citizens in these communities we're working in, or we're going to get a tremendous backlash. Equipment delays, I don't think that's a huge issue, but it's certainly something that's prominent. We have to be able to deploy large volumes of equipment, and the manufacturers are going to need to keep up. We're going to have to get to multi-carrier solutions. We're going to run out of vertical real estate, okay? So we have a lot of single carrier solutions. It's obviously a challenge to deploy multi-carrier solutions relative to power, fiber, and aesthetics, and height, but we're going to have to figure out a way to get there, or we're going to have challenges hitting that scale. And then finally, another big challenge for the industry, it's similar to the monetization. If our CapEx per site for the carriers remains extremely high, that will throttle the numbers that we're looking at. So with that, Catherine, I'll turn it over back to you. Thank you.
Okay, thank you so much, Tom. And now I'm gonna pass it on to Brian, who's gonna talk a little bit about the role beamforming repeaters will have in network densification.
Thank you very much, Catherine. And Tom, you did a great job, you know, laying out the kind of the narrative for the densification landscape and kind of some of the challenges that you know that we're going to face in doing so for 5G and finishing off even 4G deployments. And so I'm Brian Deutsch. I'm the CEO of Pivotal Commware, and what I want to do is talk a little bit about, you know, some solutions that you know we see, especially in the world of 5G millimeter wave with NR. So Pivotal Commware was founded in 2016 and built on a breakthrough in electromagnetic physics we call holographic beamforming, which allows us to shape and harness and control radio frequency waves in a very novel way that has advantages in terms of cost, size, weight, and power consumption, sometimes orders of magnitude advantages over more traditional beamforming methodologies like phased array and MIMO. You know, very early on, although our technology works the breadth of the spectrum from, you know, hundreds of megahertz up to 60, 70, 80 gigahertz, very early on, we were prompted by carriers to start solving millimeter wave problems that they saw in terms of propagation. And so the very first one we saw, which was very daunting, was this outdoor to indoor propagation problem, which has three characteristics to it: a reflection loss of the glass itself, and then has a penetration loss depending on what type of glass it is. So if it's, you know, 3-level low E glass, you're going to get 30, 40 decibels of loss. And then there's, you know, actually structural shadowing that's provided by the building itself. So we're actually shipping our first product to, you know, a North American mobile network operator Actually, they had announced our partnership with Verizon, and we're shipping product into them for their kind of subscriber-based fixed wireless access marketplace, and to ameliorate that, to in essence make a portal into bring the outdoors indoors. And so when we looked at that, we started looking at the broader network. And if you can go to the next slide. What I wanted to lay out for you was, you've seen a lot of pushback in the industry in terms of millimeter wave, and the fact that it's a line of sight propagation, and the fact that the free space loss is what it is, and viewing those very much as negatives. And I kind of want to show you the other side of that coin, and that sometimes lemons do turn to lemonade. And so I wanted to go over the densification, kind of the key to both sub-6 and millimeter wave. And certainly the pros from a 6 gigahertz and below regime are that coverage is cheap. Those frequencies propagate quite a long way. And there's a very rich multipath environment, which makes it a lot less deterministic. In other words, the signals come from many different places, but you can use that to your advantage. Also, the cons is that capacity is very expensive because the spectrum is very expensive and very unavailable, at least in big chunks. And then, so you have limited channel sizes, even with DSS and carrier aggregation. You're still, you're happy to get a 10, 20, maybe perhaps aggregate up to a 40 megahertz channel. Whereas in millimeter wave, you're talking about aggregating up to 800 megahertz of channel. So the spectrum, again, it's very limited. It's reuse is very difficult, because again, those propagation characteristics, and it's very not well suited to repeaters, because the repeater will be put in place to solve one problem, and it will create 2 or 3 others. Again, because of that less deterministic nature. So what's the problem in sub-6? It's capacity. What's the solution? Is densification, right? So it's small cells. You turn the power down and you densify. Of course, to do that, you can't use a repeater. So you have to put a small cell in, and a small cell requires fiber and requires a lot of siting and permitting and everything else that comes with it. Let's talk about millimeter wave. So the pros is that the capacity is very cheap. So the cost per megahertz pop for 28, 39 megahertz, 24 megahertz spectrum was much less than it is for say what's being contemplated for these mid-band auctions that are soon to come. Huge channel sizes, so you're aggregating that capability of multi-gigabit speeds, which we've seen with 5G rollouts, and it's incredibly easy to reuse because of its deterministic nature. In other words, it's going in a line of sight. There's not a lot of reflections. So I'm going to take that perceived weakness and I'm going to turn it into a strength. So it's very well suited for repeaters because you know where the signal is coming from and you know where it needs to go. The cons are that, obviously with millimeter wave in general, is that coverage is expensive, again, for all the reasons we just mentioned. If you get 1,000 feet or maybe a kilometer, that's lucky. And so, you have a situation where you're going to run out of line of sight anyway, even if the propagation is not an issue. And then, of course, indoor propagation is a bit of a challenge also. Although we found in our experiences, once that signal does get indoors, it's a fairly rich scattering environment. So the signal does bounce around quite a bit. So what's the problem? Coverage. What's the solution? It's the same solution. It's densification. So if you could flip to the next slide. You'll see that for densification in sub-6, the pro is that, the radios themselves. So if you're comparing an E node B, G node B sub-6 radio to a millimeter wave one, yeah, it's going to cost a little less. But the cons are the siting constraints, especially in sub-6, because the bigger antenna sizes are enormous. So the permitting and the aesthetics, weigh heavily. The costs involved and the time delay for that permitting and that siting. So you have a lot of increased CapEx, but OpEx also, because G node Bs, they consume a lot of power also. So you have a situation where ongoing costs are also impacted. Requires a fiber run. That takes time, that takes money. It creates a lot of cell edge borders. So as you shrink those cells, now you have a lot of cell edge border issues, which everybody, at least on this call, And hopefully a lot of people listening understand that that's where the real issues are actually lie for, the kind of the trade-offs that you have with cellular coverage. And then, throughput's still well below millimeter wave. So now you have a situation where you spend all the money to densify, roughly, on par with what you would need in millimeter wave. And then you're still dealing with 10, 20, 40 megahertz channels. So let's look at millimeter wave. The pros are the sighting advantages. So you'll see pictures of our product here in a second. It looks basically like you're putting kind of a Wi-Fi access point up on a pole or on the side of a building, or the side of a window, or in the parapet line of a rooftop. And so they have extremely low, what we call C-swap, cost, size, weight, and power consumption advantages. So very rapidly deployed. This is something that's a 10-minute truck roll to put it up. And then we provision it over the air. We have our own intelligent beam management service that actually uses LTE Cat1 to provision the service and do the network bring up. Now, the other thing here that really comes into play, back to the lemons to lemonade argument, is that new radio and the fact that you have this copious amount of spectrum allows for something that looks very much like IAB. It's what we call it IAB-inspired transport. So in other words, the RAN beam itself has such amazing capacity that the RAM beam can be used as backhaul. So the RAN beam coming off of G node B can actually, one beam index can run through a repeater and then through another repeater, by the way, and then, be dispersed as a true RAN beam off to, let's say, light up the side of a multi-dwelling unit, an MDU that has hundreds of residents in it. So you're able to bounce that signal around quite a bit and still get it to hundreds of end users. And so this with gigabit throughput, and which makes it obviously very, very much perfect for fixed wireless access. So now we're talking about $120 billion annual market that the carriers want a piece of to kind of nibble into what's traditionally been part of the cable monopoly. So very low capex. These units cost thousands of dollars to purchase and install, and very low opex because we're talking about a unit, especially with holographic beamforming. Holographic beamforming, the antenna draws about a watt as opposed to a phased array that can draw 50, 60 watts a piece. And so now you have a unit, even with amplification, that draws maybe 20 watts sitting up on a pole. And then of course it leverages that G node B mobility infrastructure. And now you're talking about just oodles of gigahertz of spectrums there. So if there's a con, it's just that there's, more repeaters deployed. And so the latency, by the way, on this unit is about 5 nanoseconds. So we do not decode this down to, we keep this as a layer 0 product, which takes incredible millimeter wave design discipline to do, but for isolation and to make sure you have that kind of linearity. But so even with 2 hops, you're talking about 10 nanoseconds time of flight. If you could go to the next slide. Oh, I'm sorry. You did go to the next slide. Can you back up, please? There we go. Okay, great. Thank you. Can you go to the next one? Sorry about that. And then, so let's take a look at what millimeter wave beamformers look like. So this is our Pivot product, Pivot 5G up on a pole. Down below is our Echo 5G product, and Echo, as I mentioned, is the on-window repeater that, kind of raster scans the horizon for a G node B signal, captures that signal, brings it in, conditions it, amplifies it, and then gently floods it into the interior of a room. So it can light up an entire 2,000 square foot flat, with gigabit throughput. So what we're looking at on top, though, is what we're talking about for densification, something that hangs very easily on a pole or, again, on the side of a building, and can, again, deterministically lay out a network. What's beautiful about this is that when you look at it in terms of the way an operator can lay out a network, usually they spend copiously on CapEx until then revenue comes in. So they could spend billions of dollars before they light up and start bringing customer revenue in. This is just opposite to that situation. You can spend a little bit on kind of your baseline of G node Bs for mobility coverage, and then start to hit for fixed wireless and to enhance your mobility coverage. start to bring these repeaters in, and you spend a little CapEx and you grow your revenue, spend a little CapEx and organically grow that network. It makes for, you know, a much better rollout model than what we've seen in the past. So what we're looking at here is, you know, imbues our holographic beamforming technology. So again, a very lightweight technology that takes advantage of this breakthrough, as I had mentioned, in electromagnetic physics, for this package that has amazing capabilities and performance without the kind of cost, power, and size overhead that you would get with older technology. Last slide, please. So on this last slide, we've been working on this for quite some time, and what we discovered was we needed our own modeling tool to really look at, first and foremost, kind of the unit economics of what this would do for network planning, but then also to actually use it as a network planning tool. So we can go into a jurisdiction and draw a polygon and then say to the carrier, okay, give us your basic core, in this case, say maybe 7 G node Bs into this polygon, which could be, say, a square kilometer. And so then we take that and we layer on top, and then we look at it and we say, okay, well, with that, and we're looking at using our modeling tool, which has GIS data, which allows us to kind of look at the line of sight intersect of, you know, the G node Bs with all the desired subscribers. And so we look at that and we say, okay, maybe you have 20%, 30%, 40% indoor coverage. In this case, it was 20% indoor coverage capability. Well, then we can layer in our Echo product to bring that number up. But then you're going to run into situations where you have a cul-de-sac, you have a blind alley, you've turned a corner, and it's just not worth putting another G node B up. So you have a situation where to build from 20% up to, say, 80% indoor coverage with G node Bs alone, it would cost about $1,800 per subscriber, which is cost prohibitive, you know, for subscriber acquisition in any sort. So what we'll do is we'll overlay that with our Echo product and our Pivot 5G to, again, very deterministically build and very organically build that network. And so what we'll do is we'll end up with a situation where all in to get to 80% and even beyond, you have a situation where you're talking about a sub $500 subscriber acquisition cost. And then on top of that, layer in the effect of timing. So siting costs or siting becomes much easier. No fiber runs. So you haven't lost that opportunity cost of not having those customers up and running. And and then layer on top of that, that your mobility coverage is enhanced. And now you've taken, in essence, what millimeter wave was looked at as kind of the lemons of spectrum, the nosebleed section we used to call it many years ago. And it's turned into the premium gold as far as from Pivotal Commware's perspective. That's a wrap up for me. So again, I think that what we're trying to show here is that there's many ways to skin the cat in densification. Some of them are going to be more cost effective and time effective than others. Thank you.
Okay, great. Thank you, Brian. Last, but certainly not least, we'll move on to Hongtao, who's going to discuss the importance of signal boosters and how they'll play into millimeter wave networks. Hongtao, can you hear us? You may be on mute. One moment, folks. Okay, well, Hongtao logs back in. I think he was kicked off. I will start asking some questions just to see if we can figure that out in the next few minutes. So actually, Tom, I'm gonna go back to you and ask you a little bit about the FCC's plan to streamline small cell deployment by cutting out obstacles like local fees and long permitting processes, because you mentioned it briefly. How would you say the FCC order, as well as the subsequent legal battle that continues to this day, impacted the market? And are there any other relevant updates you can get into in more detail around the regulatory battle?
No, I guess what I would say is I'm pretty up to speed through the association and what's in front of the FCC for the 9th. I think it's been well received. I don't know how likely the clarification is going to work out if industry is going to get everything we've asked for. A little more detail, Catherine, is that the 6409 clarification is asking for more delineation around when the shot clock starts in the municipality, more clarification on separation distance. There has been some dispute on equipment cabinets, concealment, environmental assessments, and the ability for tower companies and carriers to compound expand. Some of this will help in small cell densification. Some of it will really assist with macro site modification that we need. As I mentioned earlier on, we're obviously talking a lot about the small cells, but you know, the core of the network, the macro sites on the towers and rooftops that, especially in these dense urban environments, are really the backbone of the network. And in fact, in many of the small cell, one of the things we didn't talk about in many of these, you know, as Brian mentioned, in these CRAN environments, these macros operate as the fiber hub. So they're really critical to the densification. So we're optimistic on getting that clarification and allowing, again, for more streamline, more ability. I think the shot clock definition, separation distance, ability to expand the compound, some of the equipment cabinet language that's going to be in there for clarification will allow for more rapid deployment of remote radio heads and other type of architecture that's going to be needed on the macro work we need to do here, coming on all the 5G macros.
Okay, great. Thank you. And now, Brian, I wanted to ask you, you mentioned IAB inspired transport. And I just, you know, in a more general sense, where do you see integrated access backhaul fitting into this conversation around densification? Brian, can you hear us? Tom, are you still there?
Yeah, am I going to get all the questions now?
I guess so. I'm not sure what's going on. It almost as if it's on my end, but I don't.
Is that Hong?
Here? Who just spoke?
So Brian's on. Is
Right.
Hong back? So we'll take that question later.
Hong, is he back? Are you back, Hong? No. Okay, so Brian, I'm gonna, do you need me to repeat the question?
Yeah, no, I heard it. So
Okay,
IAB.
great.
So from you know, from a IAB perspective, of course, we have to wait till 3GPP codifies some standards with regard to IAB. IAB will probably be used a lot more. In my estimation, it'll be used a lot more for backhaul, probably to infill for even 4G small cells. And my guess is it would be up at 47 once they release that spectrum, because you know, you don't see a lot of subscriber equipment yet being planned for the 47 gig, so it makes sense to do that. Whereas you see, you know, a full bevy of equipment at 28 and 39. So I could definitely see IAB there. The truth of the matter is, though, with gigahertz of available capacity just through the scheduler, from the G node B with the way NR works. In other words, if a pivot's sitting on a street corner and you have, it bounces signal around the corner to 20 homes. And each one of those homes has 2 users, 2 subscribers in it that are actively using. What that looks like to the G node B is 40 people just gathered on a street corner. Well, that happens quite a bit. It's a contemplated use case. And by utilizing that, I think that gets us out from around needing IAB in the foreseeable future. Eventually, though, that would be the right way to do it, would be to actually have a transport beam rather than a RAN beam being used as transport.
Okay, great, thank you. And I'm going to check in again with Hongtao to see if he's been able to join.
There are some questions that I'd be happy to answer. I saw pop up here.
Yes, let's continue asking some questions. So let's move on to, doesn't network densification call for new entrants? You know, for example, neutral hosts to leverage common shared infrastructure. I can have you both comment on that if you'd like.
Tom's probably the more the expert there.
Yeah, Tom, go ahead.
Which one, Kat?
Just about, doesn't densification call for new entrants? For example, neutral hosts to leverage common or shared infrastructure?
Sorry, yeah. So that's a really good question. So there are some prominent neutral host players in the small cell world, as many folks know. You know, Crown Castle publicly has a large small cell play. Extenet is a large third-party neutral host small cell provider. You actually have some of the fiber players getting into using their fiber assets and their what I would say is their position in the right of way to expand and possibly become neutral host providers. So yes, there's quite a bit of that. What I would say is each major carrier today has some different strategies. Out of the major mobile network operators, you have some folks doing their own small cells quite prominently, and the majority of their small cells. You have some other mobile network operators almost exclusively going with the third-party neutral hosts. And then you have some other carriers that are using their deployments as kind of a hybrid, and doing some on their own account that they're going to own and manage, and going to the neutral host.
Hi, can you guys hear me?
Yeah, let me finish up, Hong, and I'll have Kat turn it over. So to round out that question on neutral hosts, I will say there's a lot of folks out there. There's a lot of research. There's some research articles, some white papers around what this CapEx is going to entail. And so there's a lot of folks that believe that the carriers are going to have to turn more and more to the neutral host because of CapEx needs. They need a third party to deploy the CapEx for them and then just lease. And then when you go back to my presentation around the need for possibly multi-carrier solutions on the vertical real estate that is available, that would support neutral hosts. And then the flip side of that is you have mobile network operators that want to control their own destiny and own their own assets. So I think it's early, in my opinion. We're kind of in the first, maybe we're starting the second inning here as far as small cells go. And that will be an interesting thing to see play out. How much do the carriers go their own way on their own small cells, and how much do they turn to the neutral hosts?
Okay, perfect, great. And with that, I believe Hongtao is back with us, correct? We heard you a second ago. Okay. We will continue with questions for the time being then. So Brian, I have a question here about how do you calculate the increase in indoor coverage when using AV repeaters? Go ahead. Yeah.
Absolutely. So on you know, kind of we look at it from the donor side and the service side. So the donor faces towards the G node B on the echo. And so there's about 20 dB of antenna gain. It's about a 5-degree beam. So it's very tightly focused on the G node B. And then once that signal is brought in, it goes through amplification as much as, you know, 60, 65 dB of amplification. And then it passes, you know, and it can be on either side of the window. You can either have it pass through the window first or amplify and then pass through the window. And then what we do is we provide kind of an open waveguide output to gently flood. So the idea is that we're trying to make sure that it acts as a portal, and we give copious coverage to the entire you know, indoor scene rather than focused coverage. And so that maybe adds another 3 to 6 dB in terms of antenna gain there. So what we're trying to do when it really comes down to is whatever you have on the outside of the window. So if you have, say, BRSRP of neg 95 on the outside of the window, and you're pulling 1.2 gigabits through that at, you know, with a 400 megahertz channel, that you'll have that same BRSRP about 15 feet inside. So, you know, that's roughly the link budget that you're looking at.
Hi, guys.
Hi, Hong. Okay.
Yeah, sorry.
No problem at all. We're all very.
Yeah, I was on the landline, so I got muted. It couldn't be unmuted back. I think there's a compatibility issue somewhere. Anyhow,
no
I'm back.
We're all very anxious to hear what you have to say now. So take it away.
Yeah, thank you, Brian, for filling the gap. Thank you. Okay, let me start it. So let's talk about SureCall 5G and what we bring to the table. Can we move on to the next slide? Thank you. A little bit about SureCall. I think a lot of your people are familiar with SureCall already. We've been in the industry for almost 20 years. We're focused exclusively on signal boosters. You know, over the years, we shipped, you know, a lot of boosters, you know, thousands to the North American market. We do win numerous awards, which we're very proud of. We are Inc. 5000 company 4 years in a row. We win CES Innovation Award twice, and including 2020. Yeah, we are a company that's focused and proud. Next slide. Yeah, I want to talk a little bit about the challenge of 5G from a little bit of different angle, and I think you know, a lot of people probably know this already. When it comes to millimeter wave 5G, you know, it's become way more difficult. Just look at the diagram here, right? A typical 4G base station can cover, you know, we're talking about 20 miles radius. Millimeter wave 5G base station, you know, I mean, our experience is 250 meters in terms of radius. That's about it. So huge difference. Next slide. And so, you know, coming to the in-building side, that's where our strength is. You look at this, right? I mean, traditionally, we're in-building company, and the in-building coverage for 20 gigahertz, it's non-existent. You know, you have to do something. You know, something has to be done. You know, I think at this point, the whole industry understands that, and it's just how you can do this economically. Next slide. And when we talk about 5G, so there are confusions on the market. We have essentially one of the biggest one is the FR1 with FR2. FR1 is actually traditional, sub-6 frequencies. It's not that hard actually. The coverage is still, we're talking about a similar to the 4G, base stations and networks. FR2 is the main challenge. FR2 is the millimeter wave, 6G and above, and I think that's where the whole industry is going to focus on for the next 10, 20 years. Okay, so some of the technical challenges, with going to millimeter wave, right? Traditionally, in the United States, most of the system, right, other than the Sprint WiMAX, it's all FDD system. FDD system actually is relatively easier. The uplink and downlink are separated by frequency. However, when it's going to the millimeter wave 5G, it's all TDD. So that provides a lot of challenge to the equipment manufacturer like us, like handsets, you name it, right? Base stations. That's one of the challenges has to be overcome. Another challenge, is the MIMO, is the beamforming. That I think our colleague already talked about all that extensively. I just wish we could do some of the beamforming they do. But anyhow, so next slide. Here, I want to present our industry's first 5G signal boosters. This is the SureCall False-8 booster. This is the first, to the best of our knowledge, this is the first 5G booster ever certified and on sale in the United States. It actually, covers 8 bands, including the 600 megahertz 5G band from T-Mobile. We announced last year, we're shipping right now. So that covers FR1. Next one. SureCall also announced its millimeter wave signal booster platform last year, and we're continue working with world-class carriers and everybody on those products. And unfortunately, there's a lot of things I cannot talk about, but there are things I can talk about. So I'm just excited to to see the millimeter wave coming, and it's an exciting time for boosters. For us as a whole industry, everybody included. And I'm finishing my presentation and open to all kinds of questions.
Okay, great. Thank you. And I'm actually just going to go straight to asking you a question, Hongtao.
Sure.
The other folks had their time. You mentioned that cell signal boosters will need to be modified to work with the new TDD standard. Can you just provide some more detail on those modifications and what you really meant by that?
I think a lot of that is trade secret, is patented, is everything, but I can tell you, different company has different approach, and I can safely tell you that is still a challenge for the whole industry, and it's not like you have a industry standard yet. You just don't have it. That's why this is exciting, new field, right? It's you see a lot of startup companies, new players, they all have innovative approach, and everyone is different, and it's
Yeah. Makes sense. I also have a question here for you. The question is, what exactly is a signal booster and what does it do? I guess just, can you go a little bit in more detail about signal boosters, what they do and how they do it and why they're important? You still with us, Hong? Okay. All right, so we can move back to a question for Tom, and also to keep in mind, these questions will be sent to our speakers afterwards. So if your questions don't get answered here, they will be answered at a later time. That particularly goes for questions for Hong that he seems to be unable to answer. So Tom, I have a follow-up question about the neutral host question. How will neutral hosts evolve with CBRS launch? Is there a possibility of carriers to on shared spectrum?
Yeah, so I'd say that it's
hello. Sorry.
Tom,
finish this answering this question, and then Hong, we can return to the question I asked you previously.
So I think it's early, early but exciting days on CBRS, and from what we understand from neutral host providers that we work with and carrier providers, CBRS spectrum is coming into their planning as a part of 5G. It seems, in a pretty prominent way early on, but it is early. So the small cell providers, the neutral host small cells providers we've talked about have said, no doubt CBRS will be installed on behalf of on the small cells for the carriers. Carriers have talked directly about CBRS deployment. Again, that hasn't, as we all know, that hasn't really started yet. We'll have to see how the use cases go, et cetera. But it does seem to be at the forefront of these carrier neutral host conversations. And I do think the other aspect of the question is very interesting in the sense that could you be a carrier's carrier? And there are some different conversations we've heard that are happening along that context. Possibly someone with spectrum becoming a carrier's carrier for the big mobile network operators seems to be some of the conversation. I will say that spectrum sharing in the United States has always been a unique challenge, unlike other parts of the world where spectrum sharing does occur. Spectrum sharing carrier to carrier presents, hasn't, be blunt here, it hasn't really happened. And some of that is the nature of the networks, how they have progressed over time, how the mobile network operators have progressed over time, and the fact that up until I think very recently, the carriers have used their own networks as a differentiator. And then obviously you can look ahead and determine, is that going, or make a guess, is that going to continue? If you believe that network operations and performance aren't really going to continue as a differentiator carrier to carrier, it might become a more possible, I would say, that you have spectrum sharing or carrier of a carrier out there, as we all know, because the 5G spectrum requirements are, as Brian has alluded to and Hong's alluded to, it's very, very significant.
Okay, thank you, Tom. Hong, are you there for us?
Yes, can you hear me?
Yes, I can. So we have a few questions here that want a little bit more detail about what exactly a signal booster is and what does it do. So if you could just expand, what is a signal booster? How is it different from a repeater, and why are they so important?
Sure. I have been working in the industry for almost 20 years, so I kind of know the difference. Yeah, it's not well known, and it's not in any dictionary. It's floating. So here's what SureCall thinks this is. Repeater typically is it's much bigger, expensive, sophisticated, narrow band, digitalized, a lot of bells and whistles goes into it. Booster, on the other hand, is simpler, smaller, lower power, and wideband, typically. So those are the major differences. Going to 5G, signal booster does, play a significant role because, when you look at the Verizon network, right, they call themselves ultra wideband network, right? Ultra wideband, that's exactly what the booster is. It's ultra wideband. Repeater is less, I guess the repeater is less wide than the booster is. So we all try to be wideband, but we're wider. We have longer history. So that's what I see. I mean, it's up for interpretation, and even FCC has been, fuzzy about all this. But from the ruling, you can see FCC does have the consumer signal booster ruling, which does not applicable to the repeaters. So you see the difference, right? Mm-hmm. So there is a difference. Hope that answers your question.
Yes, thank you. Okay, and mm-hmm. Brian, we have a question about the pivotal echoes in window units. Do they require a single signal from a GNOB or an ENOB? And also, while you're answering that, can you use multiple hops between these devices to get to a subscriber? And is there a downside in doing something like that?
Yeah, so the answer is yes to both. So they do need a GNOB. I mean, again, we're at millimeter waves, so the ENOBs are not really applicable. But so from an NR signal, as that beam sweeps, from the base station, we're able to capture it and get on the scheduler and enunciate ourselves as a subscriber, and then capture that signal and bring it in. So yes, it definitely does need a GNOB or a pivot. So that signal could come from a pivot. And so the idea, and then you asked about multi-hops, absolutely. So what you could do is you can go from a GNOB down a street, take a hard left with a pivot, go down that street, and then take a right into a cul-de-sac. And then in that cul-de-sac, you could have 20 homes, each one with an echo on the window. And each one of those echoes could actually be talking, through pivot to GNOB. So you could go out conceivably 3 kilometers. Now, could you go more hops? Latency wouldn't be an issue, but eventually, the signal to noise will start to degrade. As Hong well knows with repeaters, right? You do pay a little bit of a price, and in terms of noise figure. So eventually, that noise figure will climb into you. But we don't really contemplate that there's a use case beyond, 2 hops. But it allows for amazing densification with very low cost when you do it this way.
Okay, great. That was all the time we have for today. So I want to thank you all again for joining us, and a special thank you to our speakers for their insights. Remember that the video and slides will be made available on demand in the next couple of days. And please keep an eye out for my network densification report coming soon. It features all of the speakers today. And have a great day, everyone.
Thank you, Kat.
Thanks, guys.
Thank you.
Thanks, everyone.